Here's what happened in the first minutes after the dinosaurs disappeared. Source: The National Geographic. This is my most ambitious video yet, so please be sure to subscribe. Picture the sunrise on the last day of the Mesozoic era, 66 million years ago. Sunlight shines through the swamps and coniferous forests along the coast of what is now Mexico's Yucatan Peninsula. The blood-warm seas of the Gulf of Mexico filled with life. As this lost world of dinosaurs and outsized insects squawks and buzzes and comes to life, an asteroid the size of a mountain is hurtling towards Earth at around 40,000 miles, 64,000 kilometers, an hour. For a few fleeting moments, a fireball that appears far bigger and brighter than the sun flies through the sky. An instant later, the asteroid slams into Earth with an explosive yield estimated at over 100 trillion tons of TNT. The impact penetrates Earth's crust to a depth of several miles, gouging a crater more than 115 miles, 185 kilometers, across and vaporizing thousands of cubic miles of rock. The event sets off a chain of global catastrophic events that wipe out 80% of life on Earth, including almost all of the dinosaurs. This apocalyptic tale has been retold ever since the asteroid impact theory was first put forward in 1980. The identification of Chicxulub crater in the Gulf of Mexico during the 1990s then gave scientists an accurate idea of when and where the dinosaur extinction had taken place. But exactly how the fallout killed off so much life on Earth has remained an extensive mystery. Reliving the Catastrophe. Using an impact calculator developed by a team of geophysicists from Purdue University and Imperial College London, users can enter in a few key details of the asteroid that wiped out the dinosaurs, such as the asteroid size and speed, to simulate the events. You can plug in different distances from the point of impact to see how the effects change over distance, says Joanna Morgan, one of the lead scientists on the Chicxulub drilling project. If you were close by, say within 1,000 kilometers, 625 miles, you would be instantaneously, or within a few seconds, killed by the fireball. Indeed, if you were near enough to see it, you were dead, says Gareth Collins, a lecturer on planetary science at Imperial College who helped develop the program. 9 seconds after impact, an observer at that distance would have been roasted by a blast of thermal radiation. Trees, grass, and shrubs would have spontaneously combusted into flame, and anyone present would have suffered instant third-degree burns over their entire bodies. After the fire comes the flood. Depending on the local topography, the impact would have kicked up a phenomenal tsunami up to 1,000 feet, 305 meters, high. And at the low-end estimate of 10.1 on the Richter scale, the subsequent earthquake would have been more powerful than anything ever measured or experienced by humans. A seismic event of this size would be the equivalent of all the world's earthquakes for the past 160 years going off simultaneously, says Rick Astor, professor of seismology at Colorado State University and former president of the Seismological Society of America. At just over 8 minutes post-impact, ejecta would start to spill down, smothering the burning landscapes beneath a blanket of hot grit and ash. Closer to the impact zone, the ground would be buried beneath hundreds, even thousands, of feet of rubble. About 45 minutes later, a blast of wind would tear through the region at 600 miles, 965 kilometers, an hour, scattering debris and killing anything that might still be standing. The sound of the explosion would arrive at the same time, a 105 decibel sound as deafening as a jet making a low-pass flyover. A lot further away, out of range of the direct effects of the asteroid impact, an observer would witness the darkening skies and apocalyptic shooting stars created by the impact debris raining back on Earth. They wouldn't have looked quite like regular shooting stars or meteors, says Collins. Meteors burn up at higher speeds and get hotter. These would have been re-entering the atmosphere at lower altitudes, traveling slower and emitting infrared radiation. I'm not entirely sure what that would look like. Some sort of red glow would be my guess. After the red glow, the sky would darken as ash and debris swirling around the globe created a creeping twilight. For the first few hours, there would have been close to total darkness, says Collins. But soon after that, the sky would begin to lighten. The following weeks, months, perhaps even years were probably somewhere between twilight and a very cloudy day. End times. While most accounts focus on the spectacular violence of those first few minutes to days after the impact, it was the long-term environmental effects that ultimately wiped out most dinosaurs and much of the rest of life on Earth. The prevailing darkness caused by the dust cloud meant photosynthesis would have been significantly reduced. The soot and ash would have taken months to wash out of the atmosphere, and when it did, the rain would have fallen as acidic mud. Massive fires would have produced huge amounts of toxins that temporarily destroyed the planet's protective ozone layer. Then there was the carbon footprint of the impact itself, which released an estimated 10,000 billion tons of carbon dioxide, 100 billion tons of carbon monoxide, and another 100 billion tons of methane in one hit, according to geologist David Kring of the Lunar and Planetary Institute. In effect, the aftermath of the asteroid was probably a powerful 1-2 punch of nuclear winter followed by dramatic global warming. And that's where the core samples freshly pulled from Chicxulub crater can help fill in gaps in this infamous story. The drilling program will help us understand how all this affected the post-impact climate, how much material was ejected into the stratosphere and what that material was, says Morgan. Thank you for watching this video, so why not check this other cool video about what if you were the last person on Earth. Don't forget to subscribe so we can unlock the community tab at 500 subscribers.